Hello everyone, this is another video on atomic and molecular physics uh, for GATE preparation. We will be discussing some important numericals. Okay, so the first question write down the incident wavelength. The incident wavelength is 5460 angstrom, and the Stokes line. The Stokes line is at 5520 angstrom. Okay, so the wavelength of the anti-Stokes line is wavelength of the anti-Stokes line is what is the wavelength of the anti-Stokes line? We have to calculate. Okay. So first of all, this is an incident radiation in the middle. That is called your Rayleigh line. Called your Rayleigh line. Anti-Stokes line is in the right side. Anti-Stokes, and this one is your Stokes line. Okay. This one is your Stokes line. And the gap between these Rayleigh and Stokes is 6b. This is 6b, but after this is 4b. The second lines, this is 4b. Okay, so the incident wavelength is at this. The Stokes line is this. This is the Stokes line here, 5520 angstrom. The wavelength of the anti-Stokes line. So the wavelength of the anti-Stokes line is asked. So we don't have formulas for wavelength at all. So we will calculate in terms of wave number. Wave number is what? 1 by lambda. So wave number of Stokes will be how much? 1 by lambda Stokes, isn't it? 1 by lambda Stokes. So that will be 1 by 5520, isn't it? 1 by 5520 10 to the minus 10 meter. So if we calculate this, it will come as, this is of Stokes, so number of Stokes will be coming as 18315 centimeter inverse. Okay. Now what? We have the incident wavelength. Okay. This is 5520 is yeah, that's the Stokes line. Okay, done. Wait, this is not the answer. The Stokes line will come as 18116 centimeter. Okay, so incident is also there. So incident wave number will be 1 by lambda incident, isn't it? So 1 by lambda incident is 1 by how much is it? 5460 into 10 to minus 10 meter, isn't it? So that will be 18315 centimeter. Okay, so this is new Stokes, new incident, so new bar. So we know what? We know the difference between them is 6b, isn't it? We know the difference between them is 6b. That means new bar is at the center. New bar incident is this one, 18315. This is your anti-Stokes. This is your Stokes is 18116. So whatever is the difference between these two, this should be the difference here because this is 6b. So this should be 6b here. So if we calculate 6b is equal to what? New incident, new bar incident minus new bar Stokes. Okay, so new bar incident is 18315 minus new bar Stokes is 18116. Okay. 181 by 6 centimeter inverse. So this will be how much? This will be Um, should be how much? 199 centimeter. So this is your what? 6B. We don't need to calculate B. So 6B. So 6B is anti-Stokes is 6B ahead of incident. So I can write new bar anti-Stokes is equal to 18315 plus 199. That is 6B. So 18315 plus 199. That is how much? It will be 18514 centimeter plus. But this is only wave number of anti-Stokes. We are asked what? We are asked the wave length of anti-Stokes, isn't it? So wavelength of anti-Stokes will be how much? Anti-Stokes wavelength of anti-Stokes will be 1 by nu is 1 by 18514 centimeter inverse. That will be how much? That will be coming as 5401 angstrom. Okay, 5401 angstrom. All right. So this is one answer. This is how you approach this kind of questions. And this kind of question usually come in exam. Okay. So yeah. So next question. Next question is a pure rotational Raman spectrum of a line list of a linear diatomic molecule is recorded using using EM radiation of frequency nu the frequency of two consecutive Stokes line are the frequencies of two consecutive Stokes lines are. Try this question first. Pure rotational spectrum of a linear diatic molecule is recorded using EM radiation of frequencies of two consecutive Stokes lines. Okay. Okay. Options are given. Options are option A mu minus 10B mu minus 14B option B minus 4B option C mu plus 10B plus 14B option D mu plus 2B two consecutive Stokes lines. So two consecutive Stokes line, we know what the difference is. This is 6B between what? This is your relay line, anti-Stokes, Stokes. So, but during two consecutive strokes, the difference is 4b, isn't it? Difference is 4b. So you have to check which has difference is 4b. And also the relay line has frequency nu e. So the Stokes line has difference what? Nu e minus, it will always be minus, isn't it? So if you go that way, then if you see A has the right answer, isn't it? If you see A first, if this is suppose nu e minus 10b, then 4b difference, this will be nu e minus 14b, isn't it? And it should be always negative because it is less than the relay line. Are you getting my point? It is less than the relay line because see, this is your relay line Stokes. So, for example, this is 10, this should be 2, isn't it? This is on the left side. This should be 2, this should be minus 2, sorry, this should be 4, suppose. This should be 0, this should be minus 1. So, this is decreasing. Stokes line will be decreasing from your relay line, and anti Stokes line will be increasing from your relay line. Okay. So, the answer would be what? Answer will be this one. Okay. Yeah. This is the answer. Then next question. Question number 3. Question 3. Mm, in a pure rotational rotational Raman spectrum, in a pure rotational Raman spectrum of a linear diatomic molecule, the rotational constant V is equal to 20 centimeter inverse, then the separation between the Stokes line, between the Stokes and corresponding anti-Stokes line, between the Stokes and corresponding anti-Stokes line is how much? Okay. Options are 40 centimeter inverse, 80 centimeter inverse, 120 centimeter inverse, and D is 240 centimeter inverse. Okay. In a pure rotational Raman spectrum of a linear diatomic molecule, the rotational constant B is equal to 20 centimeter inverse. Then the separation between the Stokes and the corresponding anti-Stokes line is how much? 40 centimeters, 80 centimeters, 120 centimeters, 20. Okay. Again, similar kind of question. Separation between Stokes and corresponding anti-Stokes. So this will be your, again same thing, relay. This will be your relay line. This will be your Stokes, anti-Stokes. So this difference is how much? This is your 6b and this is your 6b, isn't it? This is your 6b, this is your 6b. So the total difference is 12b. Okay. But B is given, rotational constant is given 20 centimeter. So B is 20 centimeter given. See what a easy question. So 12B will be how much? 12 into 20 centimeter inverse, 240 centimeter inverse. Is that clear? It's easy, isn't it? Okay. All right. Next question. Question number 4. Just a minute. Question number 4. The rotational is the problem. Okay. Question number 4. The rotational Raman displacement for HCl molecule is 41.6 centimeter inverse. The internuclear distance between the atoms forming the molecule is. Based on among displacement for HCl molecule is this. The internuclear distance between the atoms forming the molecule is. Okay. Given reduced mass of hydrogen and chlorine is 1.61 into 10 to the power minus 27 kg. Alright, so rotational Raman displacement for HCl molecule is 41.6 centimeter inverse. The internuclear distance between atoms forming the molecule. Okay, so rotational Raman displacement for HCl molecule is given. So rotational displacement, Raman displacement is how much? If you know, Raman displacement is equal to 4b. Okay, so 4b is equal to how much? 41.6. So b is 41.6 by 4. Okay, that is how much? 10.4 centimeter inverse. We are asked what or 10,040 meter inverse. Okay, what we are asked? Internuclear distance. So for that we need to find what? Internuclear distance. I is equal to mu r square. We know reduced mass is given. If we can find I, then we can find R, isn't it? How do we find I from B? B is equal to h cut square. Sorry, B is equal to h by 8 pi square IC. That's the formula for B, isn't it? Yeah. Let's put it here. 1040 is equal to, just put the formula 6.6 and 10 to the minus 34. 8 into 3.14 whole square into I is your mu r square into C 3 into 10 to the power 8. Mu is given, isn't it? Mu is given what? A reduced mass of hydrogen and chlorine is given. 1.61 is given. So just put it here. You will get R. Okay, that's the answer. Yeah. All right. These are all right. Next question we do, number 5. If H2 molecule, if H2 molecule behaves like a behaves like a harmonic oscillator, behaves like a harmonic oscillator with a force constant, with a force constant K is equal to 573 Newton per meter, the vibrational the vibrational quantum number corresponding to vibrational quantum number corresponding to its 4.5 eV dissociation energy is how much? Okay. If H2 molecule behaves like a harmonic oscillator with a force constant K is equal to this, the vibrational quantum number corresponding to its 4.5 eV dissociation energy is how much? If H2 molecule behaves like a harmonic oscillator with a force constant this, the vibrational quantum number corresponding to its 4.5 eV dissociation energy is how much? Right. So first of all, how to do it? The frequency of oscillation of the molecule is new oscillation is equal to 1 by 2 pi root over of k by mu. Okay, new oscillation is 1 by 2 pi root over of k by mu. Now, the vibrational quantum number is asked. That is what? That is a V. Wait, we are asked V here. Okay, so we know reduced mass is what? Mu is equal to reduced mass of hydrogen molecule mh into mh by mh plus mh is equal to half mh, isn't it? Half mh, which is what? Half into mh is mass of proton 1.67 into 10 to the minus 27 kg. Okay, so from here we got mu as how much? 0.835 into 10 to the power minus 27 kg. Right. Okay. Now what? Now new oscillation becomes how much? 1 by 2 pi k by mu, isn't it? K is given, mu is, you just calculated mu, 1 by 2 into 3.14. K is how much? 573. Mu is how much? 0.835. 10 to the power minus 27. Okay. So new oscillation is, if you calculate this, you will get 1.32 10 to the power 14 second inverse. Okay. Now what we need? Vibrational quantum number, that is V. So how do we calculate it? EV is equal to H new oscillation V plus half, that is a vibrational quantum. Simple. Okay. Now EV is your what? EV is your dissociation energy. EV is your dissociation energy. This is very easy. You can do it really easily. Just put the values V plus half, and the left side dissociation energy is what? 4.5 EV, isn't it? 4.5, right? And yeah, convert it into joule. Okay, and just do it. You will get V. Okay, the answer will be 8 if you calculate it. Okay, this is simple again and easy question. This is from molecular physics. Okay. Atomic physics is also there, but this one is molecular. Hmm. So this type of questions will only come in the exam, alright? So you should be able to solve all this, isn't it? Okay. So yeah, that will be it for this class. We'll see you in more sessions.